Hello everyone. In this lecture, we will see what is the Internet Protocol suite. So, as we all know, two of the most commonly accepted and used traditional layered network models are the ISO OSI reference model, and the second is the Internet Protocol suite. In this lecture, we will see the Internet Protocol suite in detail. So here, Internet Protocol Suite, it is a conceptual framework which will provide the levels of abstraction for ease of understanding, development of communication and networked systems on the internet. Now, there are four layers of the Internet Protocol Suite or the Internet Protocol Suite. First is the link layer, second is the internet layer, then comes the transport layer, and the last is the application layer. Now, this collection of protocols is commonly referred to as, or this collection of layers, it is commonly referred to as the TCP/IP protocol suite because of the foundation technologies of this suite are the TCP and the IP. TCP is the transmission control protocol and the IP is the internet protocol. Now here, these are the four layers of the TCP/IP protocol suite: link layer, internet layer, transport layer, and the application layer. Link layer is the lowest layer, and here it is also called as the network interface layer. And these are the layers of the OSI reference model. As you can see here, TCP/IP protocol suite is having only 4 layers, whereas OSI reference model, it is having 7 layers. The link layer, it is a combination of data link and the physical layer. Internet layer, it is somewhat synonymous to the network layer of the OSI model, and transport layer is synonymous to the transport layer of the OSI model, and application layer, it is a combination of application, presentation and session layers of the OSI reference model. Now here you can see, we will see first what is the link layer. Link layer, it is the first layer or the lowest layer in the TCP/IP protocol suite. It is also called as the network interface layer, and here it will handle the physical data transmission between the devices on the same network, and this, it is analogous to the combination of the physical layer and the data link layers. That is, this layer, it is synonymous with the collective physical and the data link of the OSI models, and this will enable the transmission of TCP/IP packets over the physical medium. Now, these are some of the characteristics and their description with respect to the link layer. The alternative name for the link layer, it is the network access layer or the data link layer, and the position, it is the lowest layer in the TCP/IP protocol suite, and the responsibility of this link layer is the physical transmission of data, and it is analogous to the combination of the physical and the data link layers of the OSI reference model. Now, the link layer, it is independent of the medium in use and frame format, and also the network access, which will enable it to be used in the wide range of technologies such as Ethernet, token ring, ATM, Wi-Fi, and the frame relay. So the next layer is the internet layer. So this is the layer 2 of the TCP/IP protocol suite, and it is somewhat synonymous to the network layer of the OSI reference model. And this is responsible for addressing, address translation, data packaging, data disassembly, error detection, flow control, and the access control. And also it is responsible for routing of packets, then packet delivery, tracking operations. Addressing, it is nothing but the use of the IP addresses in order to identify the devices on the network. For example, every house will be having a unique home address, and every device will be having a unique IP address so that the data knows where to go. For example, IPv6 address, which is 128-bit, and IPv4 address, which is 32-bit. Then you have address translation, where it is converting of one type of address into the another so that the devices can communicate properly on the network. So for example, at home you will be having many devices which will be having the private IP addresses, but the internet needs the public IP address. So this address translation, which is also called as the network address translation, it will convert the private IP to the public IP and the public IP to the private IP, and it is needed to allow many devices to share one public IP. in order to improve the security and conserve the IP addresses. Then comes the data packaging, where it is a process of breaking the data into small parts called as the packets so that they can be sent across a network. And here this data packaging is required because sometimes we'll be having big data which cannot be sent over the channel at once. So what we'll do is we will divide the big data into smaller packets so that they can travel faster. And suppose if any one packet is lost, then only that packet needs to be resent, and it helps in efficient network communication. Then comes the data disassembly and the assembly. So here what we are doing in data disassembly, we have divided the packets into smaller packets so that they can travel faster. So here at data assembly, those packets will be combined in order. That is when the data arrives, that will not be in order. So here the data will be reordered. Okay, that is, it will be get back together in the correct order in order to form the original message. Then you have error detection, you have flow control, access control. You also have routing, where it is a process of finding the best path for data to travel from the sender to the receiver across the network. And you have packet delivery operations, also tracking operations, where these are the steps which are used by the network to monitor, guide, and confirm the movement of the packets from the sender to the receiver. So some of the protocols which are associated with the internet layer are the address resolution protocol. Okay, then you have internet protocol, IP, that is IP. You have internet control message protocol, ICMP, and internet group management protocol, IGMP. So this address resolution protocol, here, suppose when a device needs to be sent data to the another device on the same network, it uses the ARP, that is the address resolution protocol, in order to determine the MAC address which is associated with the destination IP address. Then you have IP protocol. It is used, this IP protocol, it uses the IP addresses in order to identify the devices and determine the best path uh, in order to transmit the data or data to travel. And these IP packets are encapsulated within the layer 2 frames for transmission. Then you have ICMP. So here it is used by the network devices such as routers in order to send the error messages and control the information to other devices. Okay. Then you have IGMP, which will allow the devices to join and leave the multicast groups and enables efficient delivery of the data to multiple recipients. Next layer is the third layer, is the transport layer. So here it is a layer 3 of the TCP IP protocol suite. It is synonymous to the transport layer of the OSI model, and here the functions of the transport layer are error control, flow control, congestion control, segmentation, addressing, and end-to-end communication. Okay. And here it is also independent of the underlying network, and the core protocols of this layer are the TCP, that is the transmission control protocol, and the UDP. It is not IP, it is the UDP. It should be UDP. UDP, and these protocols enable the transport layer to have a choice of providing the connection oriented or connectionless services between two or more hosts on the network devices. And the last layer is the application layer. This is the fourth layer, or the layer 4 of the TCP IP protocol suite, and it is here it is synonymous to session layer, presentation layer, and the application layer of the OSI model. And these are the responsibilities of the application layer. First one is it will enable the user access, that is, it will provide users with ability to connect to services. Then it can define the protocols, that is, it will establish clear rules for data transfer and facilitate the interaction for ensuring the smooth communication between users and the services, and it will enhance the experience, that is, it will improve the user satisfaction and the operational efficiency. So these are the core network protocols of the application layer, that is the HTTP, which is Hypertext Transfer Protocol, which will govern the transfer of the hypertext documents. Then you have FTP, which is the file transfer used for file transfer between computers, and SMTP, that is a Simple Mail Transport Protocol, transfer protocol responsible for sending emails between the servers. Then comes the DNS, that is the Domain Name System, which will translate domain names into IP addresses. And you have RIP, that is the Routing Information Protocol. It is a routing protocol for determining the best path for the data. And last one is the SNMP, which is the Simple Network Management Protocol, utilized for network management and monitoring. So here, these were the 4 layers of the TCP IP protocol suite. And this is the figure for network communication between the two hosts A and B, which follows the TCP IP protocol suite. So here you can see you have the link layer, internet layer, then comes the transport layer and the application layer. So this was about the internet protocol suite.